In question 1, it says a line L1 passes through the point 9, -4, and has a gradient of 1/3. It asks you to find the equation of L1 in this form, right? And specifically where A, B, and C are integers. Well, the main form that we worked with was y equals mx plus c. They give us the slope, and they also tell us the point that that line goes through. So I would substitute that into x and y, right? Because essentially x and y model all the points that are on that line, right? Any point that's on that line will be valid to substitute in there. So then I have -4, 9 times 1/3 is 3, right? Then I find that c is equal to -7. And so my line's equation would be y equals 1/3 x minus 7 in y equals mx plus b form. Then in order to do this conversion, really what I'm going to do is I'm going to multiply that equation by 3 because I've got that 1/3 there. 3y times 3 would be, y times 3 would be 3y. This times 3 would be x, and 7 times 3 would be 21, or -21. And then if I was going to rewrite that, right, then because you can notice that the form has all the terms on the same side, then I would move the 3y over, x minus 3y minus 21, right? And I'm just checking back through, and yep, A is 1, B is -3, C is -21, and so therefore all of those are integers. So I've completed that question correctly. All right, question B. It tells us first, we have some information first before we have question B. Line L2 passes through the origin, line L2, right, and has a gradient of -2. Lines L1 and L2 intersect at the point P, and they're asking you for the coordinates of point P. So, well, the line L2 would have, if I were to write the equation of line L2, I've actually got what I need, don't I? Because the slope is -2, right? And actually, if it goes through 0, 0, then the y-intercept is 0. So I already know that the equation for line L2 is y equals -2x. It's also possible that you could substitute 0, 0 into the x. You'd end up getting c equals 0 anyway, right? But you're going to need the equation of L2, right? And then it says that L1 and L2 intersect at point P, right? So essentially what I'm looking for is where lines 1 and 2 intersect. Since I have y equals -2x, and if I use the y equals mx plus v version of the equation that I found, there's L1, there's L2, then I would, based on the way that those forms have come out, I would actually just intersect them because they're both y equals. So I'd say y equals, right, then I would subtract 1/3 on this side, and I would get minus 7/3 x, because -2 is equal to -6/3, right? Minus another 1/3. And then just times times 3, divided by -7, x equals 3. And then I would substitute that back inside, y equals -2 times 3. And it doesn't matter which line you substitute it back inside, y equals -6. And so point P is 3, -6, right there. It's also possible, of course, because you had the GDC, to do this on the graphing calculator, right? And you could just do an intersection or write this equation and solve it. But either way, there are your two results for question 1.